to this video where we are required to find the gradient of the line passing through each of the following three pairs of points. And very importantly, at the top right hand corner, I have written down the formula how we could find the gradient of a line. Okay, so y1, y2, x1, x2 are just coordinates of 2 points. So every time when Mr. Tan do this type of question, I would actually label the points. Okay, so in this case here, I would have probably, let's see. I will have my x1, y1, and my x2, y2 coordinates. So if I go back to the formula at the top right, I would color code them, meaning this will be my, x1, y1 here, and x2, y2 here. And I just need to apply the formula neatly. Okay, so in this case here, my gradient of the line CD is therefore equals to y1, which will be 8 in this case. I usually like to put a bracket when I substitute values in. Y2 will be 5. This will prevent careless mistake, alright? X1, -5, minus my x2, -2. And at this point, I just need to make use of my calculator. This will give me a value of -1. Done. And I'm going to replicate this for my next two pair of lines. So this will be my x1, y1, x2, y2, and therefore gradient of EF again will be equals to my y1, 3, minus my y2, -5. X1 will be 2, minus my x2, 2. And in this case here, because the value of the denominator, if you notice, 2 minus 2 will be equals to 0. On top is 8. And every time we have this situation where we are going to divide by a 0, this will not give me any answer because for this particular case, the gradient is undefined. Okay, so gradient of EF in this case here is undefined. Alright, moving on to the last question, last line that we are going to have, GH. I'm going to again replicate what I've done for the previous two lines, which is in this case here. Again, I'm going to just make sure I write this down, x1, y1, x2, y2, so that when I substitute into the formula and I put a bracket, I will not make careless mistakes. Okay, so in this case it's -1. -7 will be my x1 minus my 3. And in this case here, I will get 0. And that will be the answer for this question. Alright, we have come to the end of this part of the video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day. everyone, welcome to this video where we are given that the gradient of line AB is 3, okay? And we are also given the coordinates of A and B, though one of the coordinate, the x coordinate of B is actually given as a variable K, which we would then have to find, okay? So the very first thing for Mr. Tan here is actually to color code it, and also to let me explicitly return it down as x1, y1, x2, y2, so that when I apply the formula at the right hand side, I would be applying it correctly. So applying that, now that we know that the gradient of AB is equals to 3, I am going to just apply the formula for gradient of AB. Okay, so y1, negative 3 minus my y2, 9, over x1 is 2. Usually I like to put bracket so that will prevent careless mistake, minus negative k, this is equals to 3, and we are just required to solve this now. Negative 3 minus 9, this will give me a value of negative 12. 2 minus a negative k, 2 positive k equals to 3. Alright. And after which, I'm going to multiply both sides by 2 plus k, so that this will be the next line that you will see. Negative 12 is equals to 3 times 2 plus k. And that will eliminate all the denominator of this equation. So let's continue to solve this equation. I'm going to multiply, expand and simplify this part here. I still have my negative 12. So this will be equals to 3 times 2 is 6. 3 times k is 3k. And I'm going to minus 6 on both sides, so that you will see this particular step. Next, okay, let me just choose a black color. So I'm going to minus 6 on both sides, so that I will have negative 12 minus 6. 6 minus 6 will be equals to 0, so don't need to consider further, and I'm still left with my positive 3k there. So continue to simplify. Negative 12 minus 6 will be negative 18 equals to 3k. So the next step would then for me to divide by 3 on both sides, so that the final answer k will be equals to negative 6. With that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are given that the gradient of 2 points is k, okay? And therefore, at the back of my mind, at the right hand side of this video, you will see this formula for gradient of a line. And I also have the two coordinates here, x1, y1, x2, y2. And so for part A, we are going to form an equation with k And after that, manipulate the equation so that it reduces to k squared minus k minus 2 equals to 0. So this part here for part A, right? I will have to make use of the formula, where I would then have y1 negative k minus y2 over x1 0 minus k. Okay, good to put brackets. And this one will be equals to k, which is the gradient of the line. So we just need to simplify this now. Okay. So at the top here, negative k minus 2 is simply negative k minus 2. As for the denominator, 0 minus k will be negative k. This one will be equals to k. And after which I'm going to multiply negative k on both sides such that I would have this. Negative k multiplied by k will be negative k squared. Last, I would then have 2 plus k squared on both sides, so that I will have a positive k squared here. I still have to minus k minus 2, and this one will be equals to 0. And I have shown for part A. Okay. Let's move on to part B, where we will then need to solve for this particular equation now. And so for part B, solving this will require me to factorize k squared minus k minus 2. This is equals to 0. So I'm going to make use of my cross chart to solve for this. So I'm going to place my k squared and my negative 2 here, and my negative k here, so that k times k will be equals to k squared. 2 times 1 is negative 2. It's positive 2. But when I multiply, then 2 times k is 2k. And then I will need to decide, how do I get my negative k? This means that my 2, I must be a negative 2k, negative 2, such that negative 2 plus k will give me my negative k. So I have successfully factorized this particular equation now. K minus 2, k plus 1. And from here, I would then be able to solve this equation easily, because one of the bracket must be equals to 0. Yes. So it's either k minus 2 equals to 0 or k plus 1 equals to 0. And therefore, k is equals to 2 or k equals to negative 1. And for part C, the last part to this question, the question let us know that the line cuts the negative y-axis and the positive x-axis. So this one will require me, right, to do some drawing at the side here, where I have my y-axis and my x-axis. And if the line has to cut the negative y-axis portion, which is here, going to color code it. I'm going to use purple color. For the negative y-axis, it has to cut somewhere here. It also has to cut the positive x-axis portion, which is here. This means that the line, the only possible case here would be something like this. This could be a rough sketch of this particular line that we are looking at, such that it can cut the y-axis, negative y-axis, and the positive x-axis. And so, this means that, very importantly, after I draw it, the gradient must be positive. And looking at the two answers, going back to the question, right, what does K represent? K represents the gradient, you know. So going back to these two possible answers, which one must be the answer? This one, because the K has to be positive from what I have drawn here. So final answer, K is equals to 2 in this case. Alright. So notice how Mr. Tan, when just given information in text, what did Mr. Tan do? Mr. Tan actually make some sketching here so that it helps me to visualize, and from there I'm able to see visually that the gradient must be a positive gradient, and that leads me to the final answer for part C. Okay, with that, we have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are given a straight line that passes through the 2 points. And for part A, we are required to find the gradient of this line. So from here, you can actually see x1, y1, x2, y2, and all I have to do, I just apply the formula for the gradient. So gradient of PR equals, and notice what Mr. Tan do. Mr. Tan, when we substitute values into the formula, Mr. Tan will put a bracket. So y1 minus y2, x1 minus x2, and after which this will give me a value of 1 1/4. Done. For part B, given that there's another point that lies on the same line, find the value of K, where the K is one of the coordinates of this point Q. Now, this is a very important clue. Okay, so if I were to just do a rough sketch of the point, okay, let me just create a space here first. So if I have this line, right, and I got my point P, and I got my point R, and now I got a point Q. What do you think the gradient of QR. What do you think the gradient of this line is? Is it the same as this line? Yes, it is, because it is lying on that same straight line. So the gradient is exactly the same. And since I already know the gradient of this line, right? So put it in perspective, gradient of QR is equal to the gradient of the line PR, or even PQ. And this is a very important clue, because if I were to do this again using these new coordinates, where P and my Q is here, then all I have to do is to apply the gradient of Q, which is 1K, and my R, which is 5, 6, easily onto the formula. So then I would have Y1, X1, Y1, X2, Y2. So K minus 6 is equals to 1 minus 5. And this one will be equals to that same 1 1/4. Okay, so let's continue to simplify this and solve for K. So this one will be K minus 6. 1 minus 5 will be negative 4, and this one will be equals to 1 1/4. So K minus 6 will be equals to 1 1/4 multiplied by negative 4. That will give me a value of negative 5. Okay, I had multiplied by negative 4 on both sides. And final answer, K will be equals to negative 5 plus 6, because I would have plus 6 on both sides. Final answer, K equals to 1. With that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.